To graph polynomial functions, we need to do three things. The first of which is to find the x-intercepts. So we're going to set our function equal to 0 because the x-intercepts are where that graph crosses the x-axis and the y values are 0. The second is to create a sign chart so we can tell whether those y values are positive or negative. The third is to create a table of ordered pairs which will fill in the gaps and help us graph our function. Lastly, when we're going to graph our polynomial functions, we're looking for turning points. So those are places in the graph where, say, the graph is increasing and then at some point it changes direction and it starts to decrease, or the other way around. It's decreasing and at one point it changes direction and starts to increase. So you can look at a given function, and if that function has a degree n, the maximum number of turning points that that function can have is n minus 1. Say, for instance, our function is y equals x to the third minus x squared minus x. This function has a degree of n equals 3. Therefore, our maximum number of turning points is 3 minus 1, which equals 2. So let's try a few examples. For our first example, we're going to graph y equals x to the third minus x squared. So our first step is let's find the x-intercepts. And we do that by setting this function equal to 0. So we have x to the third minus x squared is equal to 0. And then we factor this. We can pull out an x squared, and we're left with x squared times x minus 1 equals 0. And then we set each of these factors equal to 0. X squared equals 0, and x minus 1 equals 0. And we get x is equal to 0 as one of our intercepts, and then x is equal to 1 as our other intercept. So here we go. So we know right now this graph is going to cross where x equals 0 and x equals 1. So let's move on and let's do a sign chart. So with these factors that we've found, for x squared we want to find the sign for x squared, and we want to find the sign for x minus 1. So with our x-intercepts that we found where they cross the x-axis, we're going to put the 0 here and the 1 here in order to continue to fill in our sign chart. So for x squared, our factors are going to be positive when they're less than 0. They're going to be positive when they're between 0 and 1, and they're also going to be positive when they're greater than 1. For our factor x minus 1, the sign is going to be negative when it's less than 0. It's going to be negative when it's between 0 and 1, and it's going to be positive when it's greater than 1. Now for our function of y, so this is x cubed minus x squared, then we can tell based on these signs here that our function is going to be negative when it's less than 0. It's going to be negative when it's between 0 and 1, and it's also going to be then positive when it's greater than 1. Now these signs here tell us that our graph is going to drop below the x-axis when it's less than 0. It's also going to stay below the x-axis when it's between 0 and 1, and then it's going to rise above the x-axis when it's positive when it's greater than 1. So let's find a few more values, and then we can move on to actually graphing this function. So I've already gone through and I've chosen some values for x, and we've computed the values then for y. So when x is negative 1, it's negative 2. When x is 0, y value is 0, so it's going to cross through our origin. And we have a few others. At 0.25, we get negative 0.05, which corresponds then with our sign chart here. At negative, 0.66, that repeats, our y value is negative 0.148. And then another one just to fill in the gaps at 0.9, we get a y value of negative 0.08. So then using all of this knowledge that we've garnered, we have our x-intercept, we have our positive and negative values for y from our sign chart, we have a few other ordered pairs here from our table, so we can go ahead and graph. So we know that our graph is going to cross at a few points. It's going to cross at 0, 0, and then it's going to cross at 1, 0, because those are our x-intercepts. Now we know that from our sign chart, it's going to be below the x-axis when it's less than 0. It's going to be below the x-axis when it's between 0 and 1. And then it's going to increase and go above the x-axis when it's greater than 1. So what we need to know is what happens between 0 and 1. And that's where these values from our table come in. So if we were to plot these values here, we'd end up with a graph that looks something about like this. So we've got a turning point here where it's at a 0, 0, and we have a turning point where it's approximately 0.66 and negative 0.148 here, which that matches because if you look at our original function, our degree here is 3, therefore our maximum allowed turning points would be 3 minus 1, which is 2. So we found all of our possible turning points for this graph. So let's try another one where the degree is a little bit higher. For the second example, we're asked to graph y equals x to the 4th minus 5x squared. So already this has a higher degree than the example we just worked. The degree here is 4, so the possible turning points in our final graph is going to be 4 minus 1, which is 3. So first, let's find our x-intercepts for this function. So we'll go through the same process that we just did with the other one. We have x to the 4th minus 5x squared, and we're going to set that equals to 0. We can pull out an x squared, and that leaves x squared minus 5. That's equal to 0. And then set both of these factors equal to 0. So we have x squared is equal to 0, and x squared minus 5 is equal to 0. So then here we can factor it to x equals 0, and that's one of our x-intercepts. Here we have to do a little bit more math. We can factor x squared minus 5 into x minus the square root of 5 times x plus the square root of 5. That's equal to 0. And then you set both those equal to 0, which then is x minus square root of 5 equals 0, and x plus the square root of 5 equals 0. Solve for x. We have x equals square root of 5, and x equals negative square root 5. So here we found our 3 x-intercepts, so we know that the graph is going across the x-axis at these 3 points. So let's move on and let's see if we can fill in the sign chart to help complete the picture of what our graph is going to look like. So we need to figure out the signs, the positive and negative values for y in our function. So let's find the sign for x squared, and we'll find the sign for x minus the square root of 5, and the sign for x plus the square root of 5. So for x squared, let's see, actually we need to add in our x-intercepts here. So we have negative square root 5, we have 0, and we have positive square root 5. Okay, now moving on to x squared, we know that across the board our value for y is going to be positive. And then for x minus 5, we have a negative value here and positive the rest of the way. For x plus 5, we have negatives for the first 3 and a positive for the last. So by looking at this, we can tell that our values for y, the sign is going to be, when it's less than negative the square root of 5, we know that this is going to be a positive value. So we have a positive times a negative value, which is a negative value, times another negative value becomes positive. Then here we have positive times a positive, which is a positive times a negative, which is a negative value. And then we have positive times positive, which is another negative, same thing, a negative value. And then all positives brings down that positive sign. So we know that our graph, when it's less than the square root of 5, it's going to be above the x-axis. When it's between negative square root 5 and all the way crossing over 0, all the way to the square root of 5, the positive value of that, it's going to be below the x-axis. And then once we get greater than the square root of 5, it's again going to increase and go above the x-axis. So now let's use a strategy to help us fill in our table of ordered pairs. That strategy is called synthetic division. We'll do it for one of the x values, and then we won't spend too much time on it, and we'll just fill in the table. I'll show you those before we get to our graph. So for synthetic division, we're going to use our x value of -3. And let's fill out this chart here. We're going to look at our coefficients in our function. So our first coefficient in the first term of x to the 4th, our coefficient is 1. And we don't have a term that has the x to the 3rd power, so that coefficient is 0. Then the coefficient to our x squared term is -5. And then the coefficients to our x term and our constant term are 0 because they don't exist in our function. So we'll put that here. And then we just fill this in. We're going to bring our 1 down. And then -3 times 1 is -3. We add 0 and -3, which is -3. -3 times -3 is 9. So -5 plus 9 is 4. Then -3 times 4 is 12, -12, excuse me. Then 0 plus -12 is still -12. Then lastly, -3 times -12 is +36. 0 plus 36 is 36. So that would be our remainder for that. That is our y value, and we can add that here to our table of ordered pairs. So here again we have some values for x and y that we can use to fill in the gaps of our graph in between our found x-intercepts. So let's start to graph this function here using our x-intercept. So we know that it's going to cross at 0, 0. We know it's going to cross at -√5 and 0, which is approximately here. And it's going to cross at √5, 0, which is approximately here. So looking at our sign chart, we know that everything that's less than -√5 is going to be above the x-axis. And then comparing that to our values in our table of ordered pairs, let's look at this first one that we found, -3, which is less than -√5. So it's going to be have a y value way up here off of our axes, but we know that our graph is going to start looking at least approximately like that. So moving on, let's go ahead and plot some of these other points, -2 and -4. Then we have -1.5 and -6.19, which is about here. And then -1 and -4. So the graph is going to turn and come right back up and then look roughly like this in between our x-intercept of -√5 and the other x-intercept of 0. So then moving on, plotting our points with 1, -4 here, 1.5 and 6.19, which is about here, 2 and -4 here, and then it crosses the x-axis here at √5. And then our last point of 3 and 36, again, is way off of our axes here, but we know that the right side of our graph is going to go up like this. So what happens down here is we have a turning point way down there. So that matches all of this information that we found. For this function, y equals x to the 4th minus 5x squared, we know that we were looking for 3 turning points at the most. And so we found them. We have one down here at -1.5 and -6.19. We have a turning point at the origin at 0, 0. And then our third turning point at +1.5 and -6.19. So let's try one final example that works an application problem. Okay, suppose you're asked to find the percent of revenues that a certain social networking site garners from the years 2010 upwards to 2014. And that percent is given by the function x cubed minus 6x squared plus 9x. So the first thing that we need to do is let's fill in a table where x is the number of years since 2010. So our values for x will be 0, 2011 is just 1 year past, so that's 1, 2012 is 2, 2013 is 3, and 2014 is 4. Then we just plug in these values into our function in order to get our percent values. So 0 plugged into this function is 0, 1 plugged in is 4, 2 plugged in is 2, 3 plugged in is 0, and 4 plugged in is 4. So then we can look at these values here in our table and we can answer our next question, which can this social networking company expect to see revenues continuing to increase after 2014? So the first thing we need to do is look at this function, and the degree of this function is 3, which means that you can expect to have no more than 2 turning points. So if we look at our values here, we have a turning point where the revenues, they increased going from 2010 to 2011, and then they decreased between 2011 and 2012. So here's a turning point here. And then we have another turning point where it's going down, 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 but then from 2013 to from 2012, it's at 2, and then 2013 it goes to 0, but then so it's decreasing down to 2013. Then 2014 it starts to go up again. So we have another turning point here, which means, as I said earlier, the most turning points that we have for this function is 2. So since we've already found 2 of our turning points, there aren't going to be any more, which means that the company can safely predict that revenues will likely increase and continue to increase past 2014. So now let's use some of this information, and then we'll create a sign chart and graph this function. So here's our advertising revenue function, and then I've moved our values in the table that we did in the first part of the problem over here. So we have our X values, which represent the years since 2010, and then the respective Y values, which is the percent of ad revenue. So we need to graph this function. So the first thing we should do is find the x-intercepts. So if we take this function and set it equal to 0, x to the third minus 6x squared plus 9x equals 0. Let's first pull out an x. That leaves us with x squared minus 6x plus 9 equals 0. Within the parentheses here, we can factor this very easily. We have x times, this is x minus 3 squared equals 0. And then set both these factors equal to 0, so we have x equals 3, so already that's one of our x-intercepts. Then we have x minus 3 squared equals 0. And if you square both sides and then add 3 to both sides, you get x equals 3. So that's our second x-intercept. This is where our graph is going to cross the x-axis. So now let's create a sign chart, and we'll figure out what the rest of the graph is doing. So if we were to find the signs for both of our factors, we need to find it for x and find it for x minus 3 squared, and also find it for our total function. And then we're going to find it on either side of our x-intercept, so on either side of 0 and on either side of 3. And then if you look for x, our values for y are going to be negative when they're less than 0, and positive between 0 and 3, and positive when it's greater than 3. For x minus 3 squared, all across the board, it's going to be positive. And then that means then that our total function values when it's less than 0 is going to be negative here. It's going to be positive between 0 and 3, and it's going to be positive when it's greater than 3. So we know that it's going to, if it crosses at 0, 0, our graph here, we have our x-intercepts, and I'm going to plot here at 0, 0 and at 3, 0. Our graph when it's less than 0 is going to be here. So we need to figure out what happens up here. And so our turning points, too, that we found come in handy here. So our turning points are at 1, 4 and at 3, 0. And so we'll think about how that plays into then our values for y from our sign chart here. So let's plot these points that we found in our first table, and that'll help us get a clearer picture of what this function looks like. So we've done 0, 0. Let's plot 1, 4. and 2, 2, and then 3, 0 is done for us, and then add a 4 onto our axes, 4, 4. So going on the right side of our graph, we know that if a turning point is at 3, 0, and anything greater than 0 is going to be positive for our graph, so we know that this graph is going to continue upwards like that. And then we have a turning point also at 1, 4, so we know that we're going to connect it up here, but then it's going to turn and come back down. And there's our graph. So we know this is complete because we have our maximum 2 turning points here at 1, 4 and at 3, 0. We've plotted the rest of the points. This is what the graph looks like for our function x cubed minus 6x squared plus 9x. So as you can see, there's a few different steps in order to graph polynomial functions: finding the x-intercepts, creating a sign chart, filling out a table of ordered pairs, maybe working in a little synthetic division to help you fill out that table. And then you've got a lot of good skills in order to solve these application problems.